Hi, hello. In this video, I'm going to discuss about wireless LAN, um, single area network, OSPF, and also lastly, multi-area OSPF. So let's get started. Okay. Um, in this wireless LAN, we will going to discuss about five items. For one, wireless LAN. What is wireless LAN? For two, wireless standard. For three, security. Number four is deploying wireless LAN. And lastly, about troubleshooting. So number one, what is the WLAN, or we call it wireless LAN? So a wireless local area network, WLAN, is a group of co-located computers or other devices that form a network based on radio transmissions rather than wired. So what is the wireless LAN concept? Wireless LAN or WLAN is getting more popular nowadays as standard medium of connection to network for the end users rather than UTP direct connection. So it becomes popular nowadays because, of course, if you are using wireless LAN at your home or even the office, you can disregard, or you will not need to use cables and switch, physical switch. So in that case, that scenario, you are not going to buy or not go to additional expenses for the um additional cables or switches. So you will not required to buy that item. Okay, what is example of wireless LAN? Okay, there are two uh, example I provided here. Uh, First, home wireless LAN, and like office wireless LAN. So from the diagram on the right side, you can see we are able to see the example of home wireless setup. Okay, what are the devices or wireless devices that we can normally see from home wireless LAN? So of course, the DSL router, or second is the laptop, PC, printer, tablet, TV, smartphone, or any network device that we can configure and connect to the wireless router. So the second example is the office wireless LAN. So wireless devices, we have like ADSL modem, a firewall, wireless router, laptop, PC, server, printer, and so forth and so forth. Um, from the diagram, we are able to see that there is some like additional network devices that hold the network. So we will discuss about it. So we can have here the comparison of wireless LAN versus office wireless LAN. So from here, we will understand what is the difference between these two kinds of setup or wireless setup. Okay, home wireless LAN has no separate firewall device. Normally, um, in the home wireless LAN, uh, wireless modem or the modem are firewalls is normally built in the router as well. So that function uh, is compact to a one device or built in one device, while the Office Wireless LAN has additional firewall device. Okay, so it means there is a separate appliance, firewall appliance, which is in the network or connected network. You can see from the diagram on the right side that before getting to the router or to the LAN, there is firewall in between. Okay, what is the purpose of that? The purpose of that is to increase the layer of security and also has you can see that the router and ADSL modem separated or in the middle there is firewall. So let's discuss about wireless standard. So from here you can see that IEEE had ratified four major wireless LAN standards. This is the version is 802.11, 802.11a, and so forth. This section lists the basic details of each WLAN standards, along with information about a couple of other standard bodies. So, by the way, what is IEEE? So, IEEE stands for Institute of Electrical and Electronic Engineers and is produced um, triple triple E, I then followed by triple E. The IEEE is a professional association that develops, defines, and reviews electronic and computer science standards. In 1963, the two organizations merged to become a single entity, IEEE. So basically, commonly used version of the IEEE standard nowadays is 802.11ac. This is commonly used in home wireless network and in also in the office. Okay, number three. Number three is the wireless security. Okay, so what is wireless security? From this presentation, we will discuss about it. Um, SSID or Service Set Identifier. SSID is the name of your wireless network, also known as network ID. This is viewable. This is viewable to anyone with a wireless device within reachable distance of your network. It is recommended to set up a password so not just anybody can connect to your network. So to have security on your wireless network, you should configure your router to have or your wireless router to have a security or password for anyone to be able to connect to your wireless. So you have to provide username and also the password. So example of your SSID Bell 340. This is the name of wireless. When you do browse browsing from your laptop, from your smartphone, you will see the SSID is the name of your port. So number three is the wireless security. You can add a layer of security in regards to your wireless access, okay, or Wi-Fi protected. There is like uh, what you call standards about wireless security, which is 802, 802.11i WPA2. This is security type. You can see it from laptop or computer that you are using. What kind of uh, configured on your um, network or wireless network. Okay. Number four is deploying wireless LAN. Okay. So now I will give you a brief information about how the SSID works with another layer of security, or how to secure or fully secure your network, or even home, or even in the office. Sorry. So SSID is the what we are discussed. I forgot to discuss about the SSID cloaking. What is SSID cloaking? And SSID cloaking, it's like you are hiding the SSID. So for anyone who is trying to search, if you cloak or you hide your SSID, so no one can detect or no one can recognize what is the name of your SSID, or what is the SSID name. So in that case, you can avoid any user to browse your wireless router. So it can be configured in your wireless device or router, wireless router. There's an option there that can assign, or you can pick, or you can configure as just your SSID as hide, or you can hide from there. Number two is the security password. You have to assign password so that no one can just really connect to your wireless. And the security type, it is important to configure your wireless access or wireless modem to have to select a WPA2 uh, wireless security type, because this is very secured and not easily to hack, unlike to the other version of security type. It was already uh, exploit, or already hacked by somebody else. Lastly is troubleshooting. So the importance of troubleshooting is vital to your home network, or even your, especially in the organ or office work. By providing you this basic step, you will be able to troubleshoot your wireless case, or in the midst of issues like your device is able to connect, or your printer, your PC, etc. So first step is, if you are not able to get internet, but you are already connected to your network, you have to check your WAN connection, or WAN connectivity. This is modem which is connected to your ISP. So you can easily just check, maybe power is off, yeah, your adapter doesn't work or not plugged very well. In the LAN connection side, if you are not able to connect, you can go to step number two, verify wireless adapter. You can check from your device if, for example, for your laptop, you can just go to the device manager. If your wireless is not enabled or it's properly, driver is properly installed, you can just verify from there. Number three, you can verify AP and the router settings. So you can just go to your router and check the proper settings. Number four, you can verify your TCP/IP settings. So in TCP/IP settings, normally it is configured as DHCP. So for you to be able to connect to the wireless network, you have to set it up to DHCP by default. Okay, so sometimes you configure the TCP/IP settings manually if that is the way you configure your network. So if it is set to manual and then your setting of your modem automatic DHCP or connect or configure as DHCP, so it could not. There is a possibility that you will not be able to connect uh, to your wireless, especially if the range or the IP range is different. Okay. Number five is verify your network connection with ping command. You can just do ping from your PC or from your laptop to just ping your gateway, which is the IP address of your wireless router. Okay. Number six, you can check your wireless use. Your wireless driver is properly installed, your wireless network card is not configured very well, you can it. Okay, there is like auto uh, configure number there setting. And number seven, you can check for your security match. Maybe your password is wrong. That's why you're not able to connect with the wireless. And ensure radius is working. Number nine, check wireless security standard and user login. So it is important to make sure that your security standard and your user login is correct. Okay, check intermittent network connectivity. So what is intermittent network connectivity? It is the issue in the network which is unstable. We can say your connectivity is unstable for sometimes like it's connected for like few minutes and then after a few minutes also you are not able to connect to your wireless. So that kind of issue is very difficult also to troubleshoot, but there is a basic things you can do or can be done to check or whether you identify or you can identify this kind of intermittent work problem. So you can apply like for example like update your network card driver will help, especially if it is outdated. So that is basic troubleshooting we can do or we can apply if we are facing a problem in our wireless presentation. Hi, okay. This time we will continue we are going to discuss about the single area as OSPF. Okay, we will give you the brief information or the information about the of DR, PDR, router ID. Next start, init state, LS, LSA, LSDB, and last is the cost calculation. So first, what is OSPF? Yeah, the open shortest path first OSPF protocol defined in RFC 2328. It is an interior gateway protocol used to distribute routing information within a single autonomous system. This presentation examines how OSPF works and how it can be used to design and build large and complex or complicated networks. So, OSPF is supported, um, widely used and supported routing protocol. It is an open standard, meaning pretty much any router will support it. It is an interior gateway protocol, or IGP, meaning has been designed to be used with a single autonomous system. OSPF is also a link state protocol. So the goal of routing protocol is, of course, to learn route. Now, the way OSPF does this is by learning about every router and subnet within the internet network. Uh, the result is every router has the same information about the network as each other. Okay, the routers learn this information is by sending out what's called interstate advertisement, or LSA. So what is LSA? A link state advertisement, or LSA, is a basic communication which means of the routing protocol for the internet protocol, or IP. It communicates the router's local routing topology to all other local routers in the same OSPF area. So the way routers learn this information is by sending out what's called state advertisement. Okay. Now this LSA contains information about the subnet, routers, some other network information. Once LSA has been flooded, OSPF keeps all this information in a linked state database. Okay. This is also known as an LSDB. Okay. The goal here is to have each router with the same information in their LSDB. So that's the general goal of our OSPF. Let us take a deeper look at how this actually works. So there are three main steps to process. So first is becoming OSPF neighbors. Two routers running OSPF on the same line agree to form a neighbor relationship. Next, next is exchanging database information. The neighbor routers swap their LSDB information with each other. Finally, uh, choose the best routes. Each router chooses the best routes to add to its routing table based on the learned LSDB information. Okay, let's go to router ID. So a router ID is a 32-bit IP address that uniquely identifies a router in autonomous system. A router ID can be generated as follows: manual configured or configured by the protocol. So uh, router ID is a number that can be used to identify an individual router, kind of like an OSPF name. The router ID or read is an IPv is in the format of IPv4 address, like I mean, but could be set to whatever you like. So there are a few ways that you can set router ID. You can either set manually assign, or you can let the router to decide for itself. Here is the logic that routers go through when choosing router's ID. First, this is the manually set. Okay, if it has been manually set, the router that that is the router ID. If it is not been manually set, then the router would choose the highest up lookback IP address. Okay, so if there are no loopback interface, the router it will then choose the highest up non-loopback IP address. Essentially, it would choose the highest IP address on the router. So let's take a look with the two routers once OSPF is configured, and we have our router IDs. Routers will reach out the potential neighbors with a friendly uh, hello message. Okay, hello message. This message contains some information, including the unique router ID and already known neighbors. So hello message is also uh, let their existing neighbors know that they are still alive. Once routers to once router to receive the hello message, it run some check. Okay, so it is important to know here that there are some very strict requirements that need to be met when OSPF uh, forms a neighbor relationship. The area ID needs to be the same. Okay, this is used when scaling up. The connecting links between the two routers must be on the same subnet. Okay, the hello and the dead timers must be the same. The dead time is how long a route will wait without hearing a hello message before it is assumed that the neighbor is dead. Okay, so the default hello timer is sets every 10 seconds for point the broadcast network. Okay, so uh, if using uh, authentication, this must also match the stub area flag key match as well. So router will also need unique router's IDs. So once the checks has been made, and if it is good, then the routers can move what you call the uh, init state. Okay, so routers 2 uh, then sends hello message on its own message, not only list of its own router ID, but also routers one's ID as known neighbor. So When router once received this hello message, it sees itself as a known neighbor. This allows router to move on to the two-way state. Okay. So, first, we must look at the designated routers or DRs and backup designated routers or the BDR. DRs, BDRs are not elected on point-to-point connection. So we need to take a very quick details. Okay. Okay. Um, in this network, we have 6 routers all connected on the same segment. Let's say we don't have any DRs or BDR, and average become 4 neighbors with each other. If one link goes down, the effective router will let all the router will let all the other neighbors know what just happened. Okay, yeah, all the neighbor will know. Neighbors uh, know what just happened. Then each router that received this update will then tell all the neighbors very quickly. Things begin to get a little bit out of control, and this would happen every time change occur. Okay, so instead, okay, okay, let's define first the DR, BDR, and DR election before we continue. So DR is function of broadcast or NBMA, non-broadcast multiple access network, which operates the OSPF routing protocol. So, while BDR, an OSPF broadcast network, OSPF elects one router to serve as the designated router or DR. The another router of the segment to act as the backup designated router or the BDR. This minimizes the amount of repetitive information that is forwarded on the network. So DR and BDR election, it is an OSPF broadcast network elects one router to serve as the designated router for the DR, the another router on segment to act as the backup designated router or BDR. This minimizes the amount of repetitive information that is forwarded. Okay, so let's continue. Instead, DR and BDR is elected. The election of DR and BDR is done based on the highest OSPF priority. Now, the priority is set to one by one defaults, but it can be changed to influence the election. If the priority ties, then the election is based on the highest router ID. Happens if the priority tie. tie. Okay. When on the same segment, routers will only become full neighbors with DRs and BDRs. The other neighbors will remain in the two-way state we just look at. Then this means every router will ignore updates unless they become from the DR. So let's look what happened now. Or what happened. Okay. So the link goes down. The link goes down, and the router flags of the updates, and the router is worried. Okay. So then the DR reflags the update. Now every router pay attention. Okay. So it's good. So let's go back to this diagram. Okay. So once the exchange process starts, uh, start both the futures enter the start state. At this point, the route to select slave and master is based on the router ID. Based on the router ID. Okay, the master will control the sequence number to start the exchange process. Thankfully, we don't need to know much about more about this. Okay, now we move to the exchange state. Okay, router one sees that that router two has the LSA for 192.168.3.0. Okay, so it says can be send me over the 3.0 on network, and then sends a request. This request is good a link state request or call LSR. So router 2 responds with sure. Router 2 will respond with sure. Here we go, and send a link state update or LSU. Here we go, yeah. Okay. So router 1 sends over the link state acknowledgement, okay, or we call it LSA. Now the same happens again for router 2. Okay. Uh, Once the exchange of LSA has completed, both routers enter to the call full neighbor state. Now remember this point-to-point network. On a broadcast like we saw earlier, they will only form the full neighbor relationship with DRs, PRs. So the last step in adding the best route to the routing table, the way OSPF chooses the best route by using the metric called uh, cost. Okay. OSPF cost is a value given to a link based on the bandwidth of the interface. The sum, the sum to work out the cost is the reference value which is set on the router itself and is 100,000 kilobits per second by default divided by the interface bandwidth. Okay. So let's go for the quick cost example. Okay. First, router, the first router link is 1,554 kilobit per second. So the cost is of the next link is 64. Also the second. So R4, okay, 64 plus 64 plus 10 equal 138. So this is the cost from R1 going to R4 going to R3. And the 10 equals to 138. Now, R2 is 10. R2 is 10, 10 Mbps plus 10 Mbps plus 10 equals 30. Okay. And then R5 is 100 Mbps. 1 plus 1 going to R3. And then RT is 10, so 12. Okay, so the shortest path is R5. Okay, because it's like 12 Mbps only. It has the higher bandwidth. The shortest path. That's all. Hi. In this video, we are going to discuss about multi-area OSPF. We'll also discuss about area 0, backbone area, ABR, and so ASBR. So to continue, let's proceed to the information about the multi-area OSPF. So what is multi-area OSPF? When a large OSPF area is divided into smaller areas, this is called multi-area OSPF. Multi-area OSPF is useful in larger network deployments to reduce processing and memory overhead. What is OSPF Area 0? Area 0 is the OSPF Area 0 is very special. This is the backbone area of an OSPF routing domain. Only the backbone area can generate the summary routing topology information that is used by the other areas. This is why all intra-area traffic must pass through the backbone area. The backbone area is an OSPF. An OSPF backbone area consists of all network in the area ID 0.0.0.0. There are attached routing device, all ABRs. The backbone itself does not have any ABRs. The backbone distributes routing information between areas. So ABR, what is ABR? An area border router, or ABR, is a kind of router that is located near the border between one or more open shortest path first in OSPF areas. It is used to establish a connection between backbone networks and the OSPF areas. ASBR. What is ASBR? ASBR, a router with links outside the OSPF routing domain, is called an autonomous system boundary router, or called we call it ASBR. Let's take a look closer at how it actually works. Look at our diagram. So we are going to split these routers into areas. Okay. So an area is simply a group of routers Now it goes about saying this is a very simple five network router, five router network, so no need for multi areas. However, for the sake of simplicity, imagine each area containing multiple routers. Generally speaking, it's is recommended to have less than 50 routers in an area. Okay, but there's no real hop limit. It already depends on the processing power of your routers. When it comes to designing your OSPF areas, there are some planning that needs to be done. First of all, you need to start with area 0. This is known as the backbone area. Every other area must join to the backbone area. Secondly, to benefit from OSPF areas, you need to plan your uh, subnetting. Okay, as you can see here, area 1 has all of the 10 dot something networks, and area 2 has all of their 172.16 something uh, network. This is the key to successful OSPF areas. Okay, so let's take a look at how we can summarize our routers. The router 1 and router 2 are known as the uh, border areas. Okay. There are some special routers that have interface into two or more areas. This gives them the power to summarize route from each area. For example, router 2 and router 2 take all of the 10 dot something networks and say, hey, any package to the any packet to the 10.0.0.0 network. Okay, it's sent away. Okay, so router 3 also says any traffic for the 172.16.0.0. Okay, leave it to me. And they both sent a single route to area 0. Okay. Router 2 and router 3 will also summarize area 0 subnet to area 1. And through this route, summarization instantly wipes out all of the OSPF problems. The routing table is drastically reduced because huge subnet chunks are summarized into a single route. As a result of this, there are far less LSAs flying around, reducing the size of the LSDPs. The updates are usually contained within their own areas as well. For example, router 1 doesn't care. Okay, router 1 doesn't care if the 172.16.5 uh, network links goes down. All it knows is router 3 has all of the 172.16 subnets. So it just sends it over and let's route a free deal with it this stop the need to run the SPF every time change occurs, unless the change happens within the router's own area. The exception to this would be if the ABR interface went down itself. It would then need to tell the other areas that something terrible has gone wrong. So after some careful planning and a little extra time, we know um, We now have a scalable OSPF network using area, multi, multiple areas. Before finishing, we've already looked at the ABRs, but there are some others. Backbone routers. These are all routers that are in or partially in the backbone area. So in this case, router 1, router 2, and router 3 are the backbone routers. Okay. Area area border routers or ABR is located near the border between one or more OSPF area. So area border router is are the router 2, router 3, and internal routers. These are all routers within a single area, but not the backbone area. Router 4 and router 5 are known as internal routers. So router 4 and router 5 are internal routers. Lastly is the autonomous uh, system boundary router or the ASBR. These are routers that are connected to non-OSPF routing protocols such as the EIGRP or including also the BGP. So, for example, this may be your edge router connection to the public internet or another autonomous system network that it is that's it for multi-area OSPF. So that's the end of our presentation.